When you write programs, you want to be able to define certain paths for your program to take. With the tools presented in this course, you'll be able to tell your code to run different parts of itself under different circumstances. It's like giving your script the ability to make choices, all of which combine to help you create powerful code that will still work under many different circumstances. Conditional logic and control flow. What do those pretty abstract terms really mean? You'll come to understand more as the course progresses, but as an illustration, it allows you to start defining actions your code can take if something else is true. There are two parts to that statement. Conditional logic, which allows you to check if something is true or false. Does Bobby have more apples than Bill, for instance? Or is Jane faster than June? There's a certain conditional logic contained in these questions. Does Bobby have more? Is Jane faster? Once you have the answer to these, which can be true or false, yes or no, then you use control flow to create branches of execution. So all that combined would be, if Bobby has more apples, then give apples to Bill, for example. If Jane is faster, then give June good sneakers. So here you have the conditional part of the statement and then the control flow part of the statement. One is checking whether something is true or false, and then the control flow part is defining the actions to take if something is true or if something's false. For better or worse, you don't code in plain English, you code in Python. Here's an example of a conditional statement written in Python, something that by the end of this course you'll be able to read. Here's an example of what a more complicated execution tree might look like. It simulates the learning process for a Python student. While true is a loop that goes on forever. If Python is awesome, if not overwhelmed, then you learn. If you're overwhelmed, then take a break, continue. If you need to sleep, break, else continue, and then reflect on your learning. But if Python is not awesome, then you just take a break until Python is awesome again. In any case, don't worry about all these keywords like continue, break, if, elif, else. All of this you're going to cover in the course coming up. Something else that you'll cover that's related to control flow is error handling. Errors happen, mistakes happen, and you want a way for your program to be able to handle errors if they come up. There are ways for you to handle specific errors and to keep on running if these errors crop up. To summarize, in this course, conditional logic and control flow, you're going to be covering conditional logic, control flow, and error handling. Add some logic to your code. You're trying to find out whether something is true or false in Python. Now, how do you do that? Conditional logic allows you to check if something is true or false. So, it involves questions like, does Bobby have more apples than Bill? Is Jane faster than June? Is 5 larger than 8? Well, that's something that we know to be false. Is N before P in the alphabet? That's something we know to be true. Basically, when you're writing conditional logic in Python, you're looking to reduce some values into a true or false, and usually do that by comparing them and combining them with other statements. In this lesson, you're going to cover a few operators and how they fit together. Boolean comparators, conditional statements, logical operators, and operator precedence, that is, in what order things get resolved, in the same way that mathematical operators have a certain precedence. Multiplication happens before addition, for instance. Boolean comparators and logical operators also have a precedence. Boolean comparators are some of the most common operators you'll use for comparing values. All these operators require an item on the left and the right, and they compare the values. The greater than operator, a chevron facing right, asks whether the value on the left is greater than the value on the right. The less than operator, which is a left facing chevron, asks whether the value on the left is less than the value on the right. A nice way to remember these is to look at the chevron as a mouth. and whatever the mouth is trying to eat should be the larger of the two values for that expression to evaluate to true. The greater than or equal to operator is a right-facing chevron with an equal sign. The less than or equal to operator is a left-facing chevron and an equal sign. The greater than or equal to and less than or equal to operators are similar in that they do the same thing as the greater than or less than operators, except if the values are equal, they will also evaluate to true, whereas the simpler counterparts will actually evaluate to false if the values are equal. The not equal to operator, which is an exclamation mark and an equal sign, is just asking whether the values are not equal. So if they are equal, that will give you a false value. The counterpart to that is the equal to operator, which is two equal signs. The equal to operator will only give you a true value if the values on either side are equal to each other. It can be difficult to grasp what these operators are really doing by looking at them in isolation like this. So coming up, you're going to be looking at some examples. All the following conditional statements will result in a true value. For these examples, I'm not going to call the operators by their name. I'm going to read out what characters they are. So the first example will be 10, right-facing chevron, 5. But when you're actually reading code, if you were to read it out loud, you wouldn't say 10, right-facing chevron, 5. You would say 10 greater than 5. But after these examples, I'm going to start calling them by their real name. So 10, right-facing chevron, 5, asks, is 10 greater than 5? Which is true. 1, left-facing chevron, 2, asks, is 1 less than 2? Which is also true. Remember, all of these examples on this page will evaluate to true. 10, right-facing chevron equals 9, asks, is 10 greater than or equal to 9? Which is true. The next example is 5, left-facing chevron equal sign 5, which asks, is 5 less than or equal to 5? Which is true. 1, exclamation mark equal sign 0, asks, is 1 not equal to 0? Which is also true. And finally, 100, equal sign 100, asks, is 100 equal to 100? Which is true again. Now you've seen a bunch of conditional statements, all of which evaluate to true. Now it's time to look at some that will evaluate to false. The first example is 10, left-facing chevron 5, which asks, is 10 less than 5? Which is false. The next example is 1, right-facing chevron 2, which asks, is 1 greater than 2? Which is false. 10, left-facing chevron equal sign 9, asks, is 10 less than or equal to 9? Which again, false. All of these examples are false. 4, right-facing chevron equal sign 5, is 4 greater than or equal to 5? False. 1, equal sign 0. 1 is equal to 0. Is that a true statement or a false statement? 100, exclamation mark, equal sign 100, asks, is 100 not equal to 100? Which is false. All right, so from here on out, I'm not going to talk about chevrons, equal signs, or exclamation points. I'm just going to call the conditional operators by their name. Now that you've had a look at Boolean comparators, now it's time to add logical operators to the mix. There are 3 logical operators in Python: the AND operator, the OR operator, and the NOT operator. The AND operator and the OR operator require values on either side of the operator. The NOT operator only requires a value on the right side of it. The values that the logical operators work on will be evaluated as Boolean values. That is, doesn't matter what you put on either side of the AND operator, it will always try to see the values as true or false. So it's like asking, is it dinner time and am I hungry? On either side of the AND keyword, you have questions that can evaluate to true or false. So in the case of AND, if both are true, then you'll have dinner. On the subject of AND, that's the first keyword that you'll be taking a look at. So if you have a statement with which the left side or the right side evaluate to true and one of them evaluates to false, then that will give you a false value. If both the left and right sides are true, then you'll get a true value. If both sides are false, then you'll get a false, because none of them are true. And again, if one side is false, then AND will always return false. So the only case in which AND can return true is if both sides of it are true. Now it's time for OR. With OR, only one side of the operator needs to be true. If both sides are true, then that's also true. The only case in which it will be false is if both sides are false. And the not. The not only needs an expression on the right-hand side, and basically it will just invert it. So if you have not and an expression, and that expression evaluates to true, then the total result of everything will be false. If your code says not false, then that expression evaluates to true. If your code says not true, then that expression evaluates to false. It inverts the value. So now you're going to take a look at a couple examples of some logical operators in action. So say you had an expression of 1 is greater than 2. Then you added the AND logical operator, and then had another expression on the right side of it, as 5 is greater than 3. So what is your best guess at what this will produce? Well, you can break it up into bits and say 1 is greater than 2. Is that true or false? That's a false statement. 5 is greater than 3. That's a true statement. So you have a false statement and a true statement on either side of the AND operator. That gives you false, because for the AND operator, both sides need to be true. Take a look at another example. So you have a string, Python, and you want to see if it's equal to another string, Pythonic. Then you have the OR keyword, and you have 10 does not equal 9. So what do you think this will give you? Again, take it by bits. You got Python is equal to Pythonic. Is that a true or false statement? That's a false statement. And then you have 10 is not equal to 9, which is a true statement. So what will the whole thing give you? It gives you true, because with the OR operator, either side need to be true. So now what happens if you just copy this and then add a not in front of the whole expression? What do you think this will give you? Now you might be tempted to think that this would give you false, but in fact, the not operator is operating on this expression before the whole OR expression is evaluated. The not keyword is operating on the expression of Python is equal to Pythonic before the OR operator operates on either side. So before the OR operator gets a chance to evaluate, not Python is equal to Pythonic evaluates to true. And then 10 is not equal to 9 evaluates to true as well. Since OR either side or both sides can be true, gives you true, you get a true value. Now, the way that not operates first before OR is to do with operator precedence. Some parts will evaluate before other parts. The Boolean comparators are the first to evaluate. After, it's not, then and finally OR. You can work around this behavior if it's not convenient for your use case by using brackets. Whatever's in brackets will evaluate first. So if you run into any strange bugs and the expression is not behaving as you think it should, make sure it's not to do with the operator precedence. Break up your statement into small pieces and see if it still works there. All right, in this lesson, you've covered Boolean comparators, conditional statements, logical operators, and operator precedence. Remember, this is all just about taking values, comparing them with each other, and getting a true or false value at the end of it. Now, you might be wondering about the precedence between the Boolean comparators. That wasn't mentioned in the previous slide. They were just listed all on one line. And say you had an expression like this: 10 less than 50 greater than 20. What would evaluate first in this situation? This gives you true, but why does it give you true? Because if you do 10 is less than 50, you get true. But then would you be saying true is greater than 20? That gives you false. So what if it was 50 greater than 20? That gives you true. But is 10 less than true? That's false. So why is this giving you a true value? Well, the reason is that in Python, whenever you chain comparators like this, it will implicitly add an AND operator in here. So then the expression on the first line, 10 is less than 50 is greater than 20, is actually evaluated as 10 is less than 50 and 50 is greater than 20, which will give you the true value that you got at the beginning. Chaining Boolean comparators in this way can be useful for ranges. You usually don't use chained Boolean comparators opposing each other like this. A statement like that could easily just be written 50 is greater than 20, because checking if 50 is greater than 10 is redundant in that case. But it is useful for checking ranges. So say you had age equals 20, and then you want to check if that age is between 10 and 30. So you can go 10 is less than age is less than 30, which is true, because that is evaluated like this. 10 is less than age, and age is less than 30, which will give you true. So you don't need to chain operators, but it can be a nice shorthand for ranges. And therefore, the Boolean comparators don't have any precedence between them because there is an implicit AND inserted between them. So no matter what, there's never any ambiguity as to which Boolean comparator to evaluate first, because they are separated by AND keywords. So they all operate independently, and then the AND can evaluate. One final thing to bear in mind about comparisons is when you're dealing with strings, Python uses alphabetical order. So A is less than Z is true because A has a smaller index than Z does, because A comes before Z in the alphabet. It also sorts strings lexicographically. Now that's just a fancy word for saying alphabetical order. So if you had A is greater than AAZ, what do you think that would give you? That would give you false, because it looks at the first letter, which is A, so they're equivalent, looks at the second letter, A, which is equivalent, then it looks at the third letter. And since A has a smaller value than Z does, that gives you false. So that's just something to bear in mind when comparing strings in Python. It's all very well to read and to listen and absorb all this information about Boolean comparators, logical operators, operator precedence, but until you actually get your hands dirty and see it in action, it's never really going to sink in. So in this lesson, you're just going to look at a couple more examples of some more complex expressions. So the first example reads, true and not, open brackets, 1, not equals 1, close brackets. So what do you think this will evaluate to overall? Okay, so you have that expression typed out as a comment, and that's just not to give the game away. We want to try and work out what this is without actually executing it first. So how would you go about understanding a complex expression like this? Well, let's break it up into little pieces. You know that operations in brackets evaluate first. So what is 1 not equal to 1 evaluate to? 1 not equal to 1 gives false because 1 is equal to 1. So now you can rewrite the expression as true and not false. Okay, so what's next? And or not? Not is next. What does not false evaluate to? Remember, it just inverts the value, so that would be true. So now you can rewrite the expression as true and true. What would that give you? What does and need to evaluate to true? It needs both sides to be true. So if you do true and true, you'll get true. So now take a look at example number 2. This one reads, open brackets, A in quotation marks, not equal to A in quotation marks, close brackets, or not, open brackets, 2 is greater than or equal to 3, close brackets. Take a quick look at this and go to the REPL and see if you can work it out. Okay, as before, you've got a comment here, so you can see the whole expression without evaluating it and giving the game away. So here you have a complex expression. How do you break it up? Well, you start off with the things in brackets. Look at the first one. A is not equal to A. It gives you false, because the string A is equal to the string A. So now you can rewrite the whole expression as false or not 2 greater than or equal to 3. So what's next? It's the other expression in brackets, 2 greater than or equal to 3. So is that expression evaluate to true or false? Is 2 greater than or equal to 3? No, that's wrong. 2 is not greater than or equal to 3. It's less than 3. So that will give you a false value. So now you can rewrite the whole expression as false or not false. So what comes first, or not? Not comes first. So not false, what will that give you? It inverts the value, so it will give you true. Now you can write the final expression as false or true. So what does or need for it to give you a true value or a false value? Or only needs one side to be true or both sides to be true, and it will give you a true value. So if we just type that out, you'll see that now you get a true value. So let's just copy the whole expression to verify that, and indeed it is true. You just went through a couple of examples showing you how to figure out step by step how a complex expression evaluates. You've taken your knowledge of operator precedence and applied it to these expressions to see which ones go first and how it reduces into its final value. To really internalize all of this, the best thing is to practice. Come up with your own complex expressions, use variables to store the values of expressions, assign the results of expressions to variables, mix and match, come up with interesting chains of Boolean comparators and logical operators. Understanding is not enough in programming. To build fluency, you need to practice.